What are flames, scientifically? Combustion releases energy and, in some reactions, some of that energy is emitted as light. The rest is emitted as other types of electromagnetic radiation. What light depends on the chemical reaction involved. As you can see, carbon, which is one of the most common elements we burn, gives off a lot of red, yellow and orange light when its atoms are excited. By contrast, hydrogen top hardly gives off any light. However, fires give off a lot more heat than light. That's why burning wood, or heating oil, or natural gas keeps you warm. Wood is mostly carbon, hydrogen and oxygen atoms with some other atoms mixed in. That's what gives it pretty colors when it burns, like yellow, greens and deep reds. Natural gas and oil contain more hydrogen, so their flame is less pronounced than burning wood. So, there's all kinds of things going on in a fire, both atoms combining to form new atoms. Carbon plus oxygen equals carbon dioxide, plus atoms absorbing energy from nearby atoms and giving off light, like red-hot coals, constantly absorbing energy and giving off light. Some materials have completely different characteristics. Sodium, for example, gives off almost all of its energy as yellow light in a very narrow range. They were used as highway lighting for a while in Ontario because for the given energy they would give off a lot of light, and color doesn't matter much at night, you want intensity. And this one is magnesium. Magnesium gives off a lot of light when it burns, it's almost pure white. However, it also gives off a lot of ultraviolet light which can damage your eyes if they're not protected. Glass is fine. The heat generated from the phosphorus is enough to break down potassium chlorate, and in the process, it releases oxygen. This oxygen combines with sulfur, allowing the flame to thrive long enough for us to light a candle or barbecue. As the video also states, a chemical reaction where latent energy is released. This might need Vic, the Quora particle theory guy, in here. What doesn't happen in flames, of which I can't explain the natural processes, is oxygen in the atmosphere ever combusting. A good thing, since if could, the entire atmosphere would explode from one spark. One observes a flame wicking up, while surrounded by billions and billions of oxygen atoms in the air, and these never combust or assist combustion. Every O atom in every flame originates from the ignition material by chemical reaction. The term, chemical reaction, doesn't offer any insight as to which chemicals or what reaction. You've posed a really tough question, but the match video is really cool and shows the gradually spreading chemical reaction in which latent energy that existed in these materials in rotational dynamic form that existed there pre-ignition, are released in outward expanding linear-like path with visible particulate debris. Combustion. An exothermic reaction. The reaction going from the materials that are burning to what is left after the burn and giving off heat as a flame in the process.